Okay, we have our first presentation for today from Bill Christie of the USDA Forest Service, who is going to be presenting on mapping forest change from Hurricane Ian using Google Earth and Sentinel-2 imagery. Before we kick to Bill, the purpose of this is to brief the committee on mapping tools that use cloud-based the cloud-based Google engine to study changes in forests, specifically focusing on mangrove cover following Hurricane Ian. And the connection to the CCMP relates to fish, wildlife and habitat protection, priority action 1, to protect, restore and monitor estuarine habitats. And with that, Bill, are you ready to go?
I am. Can you hear me okay?
You can indeed.
Very good. Thank you all very much for the invitation, and I look forward to presenting this new tool. My name is Bill Christie. I work for the U.S. Department of Agriculture Forest Service. We are, our research work unit is in the research and development portion of the Forest Service. And probably our prime mission directive is to generate knowledge and tools. And so that's this is our opening kind of web page of our website, the Eastern Forest Environmental Threat Assessment Center, sometimes referred to as EFATAC and sometimes as the Eastern Threat Center. And so what I'm going to present to you today is a tool that we've produced for tactical mapping of forest disturbance. Next, please. And so I don't know whether many of you have heard of Google Earth Engine, but it's a huge repository of satellite imagery and other data sets that Google has put together. And there are, probably literally acres of server farms that serve this application. So you can do you can access these data sets, remotely sensed data sets, and process them in seconds. It's so fast. And so we've been working with this since Sentinel came out, probably about 6 years ago. And so that's what I'm going to show you today. And I need to recognize my colleague, Steve Norman. He's the other co-developer on what we call HiForm, and I'll explain that in just a minute. That stands for High Resolution Forest Mapping. That's what we've named this tool that I'm going to present to you today. And my emphasis in presenting to you today is twofold. One, I produced a really nice data set, 1 year forest change that I've made available to you. And then secondly, part of my job is to outreach these tools. And so part of that mission is to create tools and knowledge and, give it away. So we create the tool, you've paid for it, we're giving it back to you. And we hope that the members of the partnership and the partnership itself can maybe make use of this tool. And we are certainly available afterwards to help you understand how to use it and to get you started for any of the partners. Next slide, please. And the reason we like Sentinel so much, everyone, the best that was available for 20 years was Landsat. And so that was fine. That was 30-meter data. So it's around 100 by 100 feet. If you think of it in stories, building stories, it's a 10-story building laid on its side by another 10-story building laid on its side. And that's the resolution, the spatial resolution that you're getting. And so for the longest time, that's what we had. Well, around in 2015, Sentinel came out. This is a European Space Agency, and they are offering 10 meters. Now, Landsat does get to 15 meters on a panchromatic mode, but you're losing some spectral information there. So in this grid, the orange is the Landsat 30-meter grid. And within that, at a resolution of 9 times better, is the 10-meter Sentinel-2. And if you'll notice on the right, some of those deciduous crowns, some of the larger trees actually fill up a 10 meter, a 30-foot pixel, a 10-meter pixel. And so that's why we call this near tree crown resolution. And that increased resolution, 9 times better than Landsat, combined with a color ramp that we've created, actually produces some of the most outstanding uh, forest disturbance maps we've ever seen. So that's why we're so hot on this Sentinel. It comes into Google Earth Engine the day after acquisition, whereas with the Landsat, I don't know what it is, but it often takes weeks for a single image of Landsat to become available in Google Earth Engine, and I just can't wait that long in some cases. So that's why we are pushing this Sentinel-2 so much. Landsat is available in our mapping tool as well. Sometimes through cloud cover, Landsat's the only thing available, and that's fine to use. Next slide, please. And so what I'm going to just get some terminology down. If no one has ever seen kind of the interface of Google Earth Engine, they have what's called the code editor. And it's through this application. I should mention that Google Earth Engine is all cloud-based. There's nothing local. It's free. You acquire an account and you interact with the application through this code editor. And literally, it's a blank sheet. I won't talk about the specifics of the various panels, just to say that it can be intimidating. I'm not a programmer, but I can edit code. And there's plenty of code out there. And just for everyone else in the audience, you don't have to be a programmer. You just, in this case, using the default interface, it is a little intimidating. And all you really have to do is know how to change a certain piece of a line, change the date. And so a lot of our scripts are in this left-hand form. And so over the past 6 years of developing this tool, our methods have been honed and sharpened, and we know what we're doing. We know how we like to do it. And so we call it this workflow. It involves masking, the use of masks. It's the metrics that we use behind the scene to calculate NDVI change. It's our methods that we use to calculate it. And it's also the visualization of the change. And so because it's so intimidating on the left, we created an interface that sits on top of it. Next slide, please. And so in that red box, we just created a little user interface that sits on top of Google Earth Engine. You choose literally by the numbers. We tried to make it just as easy as could be. So this is a way of interacting with Google Earth Engine where you don't really have to know how to program, or you don't have to look at the details of a script or go hunt and find a line number. You can just choose your satellite, which we usually just leave it to the default Sentinel. Landsat's back in there as well as a drop down, and you set your pre and post dates and you press go, and that's it. Do the change analysis and it returns all these layers, and there's our color ramp that we use. And so it's a simplified user workface. It executes a customized set of tasks, which we call the workflow, the high form workflow. High form meaning high resolution forest mapping. But it's very difficult to modify the code. It does one thing, a couple things really well. But if you want to alter that program to do something special or specific, or clip it or merge it or whatever, it's hard to do. It's very hard to modify the interface that sits on top of the programming. And so we usually come back to that left-hand side and just create our own scripts. And that's what produced the image I'm about to show you. Next slide. Oh, more information about HighForm, the website, highform.org. And then down below that red arrow, that mapping workflow, that's a really important web page. But this will introduce you to the tool, show you examples of past disturbances that we've mapped. And just feel free I'm available for anyone who has questions with regard needing more information. So next slide. So the high form workflow, as we call it, and using cloud-based Google Earth Engine produced this NDVI change map. It's forest mass. So this is 1 year forest NDVI change. And literally, folks, it did this probably in less than 5 seconds, maybe 3 to 5 seconds. It produced this 1 year NDVI change map. And so I created this, what's called a web map in ArcGIS Online speak. And I've shared it with the group. It's public. You don't have to have an ArcGIS Online account to view it. And then on the left, there's my layers that I've created and put in there. And, I went online and found that the hydrologic unit codes that you all work in, that the partnership works in or has responsibility in. So I just went out and grabbed those hydrologic units and then clipped the imagery to only that area. And so on the left, we're highlighting. On the next few slides, I'll highlight what layer we're looking at. And so let's zoom in. Next slide. And so I think this is right where you all are meeting today. Isn't that right? I'm just zooming in and seeing. So this is 4 classes. This is 1 year NDVI change. And this, what is determining what's forest is NLCD 2019. If you know, National Land Cover Data Set, 2019 is the latest one. And so I just pulled all the forest classes out of there. There's 3 forest: deciduous, coniferous, mixed, and woody wetland. And I added one more. I threw shrub and brush in there because sometimes the NLCD data set is not as accurate as you'd like it to be. And I wouldn't want to shy any land cover that you all need to look at. So and you can zoom in further, and we will. And so next slide, please. So if you'll notice on the left, I've just turned on a mangroves layer. And so I know that, I took a lot of assumptions here. One was how many hydrologic unit codes you all work in. And the other one was I'm assuming that you all want to know information on mangroves. So I searched a couple area sources for a mangrove data layer, and I've decided on this one from the state of Florida, a statewide land use data set that the state has put out. I don't know the date. I think it might be, someone there might know better the date. I think it's rather old, maybe around 2010, 27, if I'm not mistaken. I'm guessing at that. But if you can toggle back, who's doing the slide, if you can toggle back 1 and then toggle forward 1 and then back 1 and then forward 1. And so that's one way where you can reduce what I'm calling forest to what the state is calling mangrove. So you're filtering what you're looking at. And all I did here was put a mask on there that kind of hides the other non-mangrove land cover. And so let's zoom in a little bit more, and next slide, please. So this is, if you'll notice on the left in the table of contents, it says pre-Hurricane Ian color infrared composite fall 21. So that's the pre-image. And I tested putting a natural color image, like an aerial photo, as opposed to this bright red color infrared rendition. And the natural color just didn't kind of show. It was hard to see detail in the pre and the post. It was dark. I probably could have done a better job enhancing it, but I decided on this color infrared. So that's the pre. And if you advance the slide 1, there's the post Hurricane Ian, fall 22 to spring 23. And if you could toggle those, go back 1 and forward 1, back 1, forward 1, you can kind of compare the pre-conditions to the post conditions. And so if we go one more forward, advance one more, there's the NDVI change image. And now if you toggle one back and one forward, you can kind of see where tonal changes in the post image relate to NDVI change values that we've mapped. And so next slide. So there's just two more slides, and I apologize for throwing all the heavy stuff in one bucket in one slide at the very end where I say, y'all, thank you and have fun. Mapping NDVI change is the easy part. You know, our tool, anyone can use it. It produces 10-meter NDVI change images in seconds. That's the easy part. But the tough part comes from assessment and attributing change. And it can be nuanced, and sometimes it requires expertise. And that's why I'm so glad I have a research ecologist PhD beside me, where I give him all the hard questions, and I take care of the technical details. But that's the tough part of this. So I would caution having a novice perform kind of vegetation change analysis. So you want someone with some knowledge of vegetation patterns and landscapes. And so just addressing some of these, and I apologize, this is kind of a catch-all at everything. So bear with me. I apologize. It's all in one slide all at once. So NDVI is just a measure of greenness, and that's all we're doing here. Is we're creating NDVI's normalized difference vegetation index. It's a widely used index. It basically measures the amount of greenness. And so we create a greenness image for the pre, a greenness image for the post, and it's literally subtraction. That's all we're doing here. We're not doing percent, we're doing absolute change. So it's easy to understand. And so that's the reason we use masks, because agriculture is highly variable, and boy, it turns out, just highly departed with a lot of change. So we just mask our imagery to what we want to look at and kind of not throw away all the other stuff, but kind of push it to the background where we can focus on the land cover that we're looking at or that we're interested in. Change is also positive and negative. And, if you do restoration work in areas, this tool you'll see a positive increase in NDVI change, and that's measured in that. There's also species susceptibility. In the Mid-South here, we have broadleaf species, severe weather, leaf strips trees. So it may show up as really highly departed. Well, in 3 weeks later, and the leaf back out, it's highly ephemeral, and there was hardly any severity to it. So species susceptibility can require some expertise with regard to interpreting NDVI change. Field verification, calibration. We've had folks take our imagery out, or change imagery out into the field and associate severity with levels of NDVI change. And so that way they can kind of calibrate the data set as to severity levels. Mid and South Florida, a lot of cloud cover. There's methods used to composite multiple dates of imagery to kind of get rid of clouds by looking at multiple images, taking the best of multiple images. Essentially, that's what we call max NDVI compositing. That's one way to get around clouds and cloud effects. And then the quality or the of the masks that are used. I told you I'm using NLCD 2019. Well, that's not current, and maybe the landscape, these coastal landscapes that you all are interested in, maybe they don't change a lot, and they don't. And so maybe the masking is not a big deal with regard to not looking further inland. You want to choose the same phenological timing for the pre and the post images. You don't want to mix phenological phases. And then areas of omission, areas of commission. With regard to Hurricane Michael, we were very fortunate that the day after Michael's landfall, after it blew through, it was perfectly cloud free, and Sentinel-2 went over that day. So we had a perfectly cloud free imagery of post Michael forest disturbance. And so an example of error of omission with that, you might think that that's really a good thing. And it was nice, it's unusual, but this is where the problems were, these two types of errors. Errors of omission means you have classified something as not disturbed and it was disturbed. And so an example of an error of omission in remote sensing speak is with regard to Hurricane Michael. Say we had a lot of blown down trees. Well, they're still green. The vegetation underneath is still green. The shrub layer is still green. You might have lost just a little bit of NDVI value because everything's still green, but the trees are laying on the ground. And so that's an error of omission. If you come back in 2 weeks and remap it, you're going to really see a much different story there. And so an error of commission is saying it's disturbed, you're mapping disturbance when actually it wasn't disturbed. And with regard to Hurricane Michael, an example of an error of commission with the storm, with the overpass of the satellite, the next day, there was still a lot of standing water on the landscape, standing water covering green vegetation, the sensor not sensing green vegetation there, but water, and then the change would be really high. So there's, this part of assessment is really where the power and where you need the expertise. And then just one final kind of disjunct thought is long-term vegetation recovery and monitoring. Sentinel only goes back to 2015. Landsat goes back to like 84. So with some of the Landsat data sets, you can do longer-term vegetation monitoring and recovery. And one tool, you can do that with our tool as well, but there are other tools. I'm thinking of one specifically based on Google Earth Engine. It's called the Climate Engine. And that's a tool where you can drop a point or drop a polygon on a piece of land or vegetation and get a long-term NDVI signature. And so by doing that, you can see when the hurricane or when the storm occurred and its initial impact on forest. But what's even more important is that you can see year after year, you can judge how much the NDVI has recovered to the pre-disturbance state. Sometimes they never do recover. Sometimes they do. And then one final thought with doing that, you can compare different storms. Irma versus Ian. You could use Climate Engine to look at the two different curves and characterize their effect on the landscape and comparing two different, drastically different storms at two different times and see what's recovered and what hasn't. So next slide, please. So that's my final slide here. And so hit that website, the HiForm website, for more information if you think that this tool can help you going forward. And you can, rerun this yearly. You could just change a date. You can save out the script that produced your change so you can always come back and replicate your work. And so we just find this incredibly useful at 10 meters for identifying and measuring, mapping forest change. You can monitor recovery and restoration work and derive measures of success. And measures of success can be qualitative, it can be descriptive narrative, or it can be quantitative. These pixels have certain surface area and certain departure values. So, you can derive quantitative kind of change statistics and recovery statistics from that. So those are our emails. If you need to contact me, william.m.christie@usda.gov, and the research ecologist, stephen.norman@usda.gov. The HiForm website, hiform.org. Earth Engine sign up, earthengine.google.com. And I'm open to take any questions, and thank you all very much for the invitation. I hope you find this useful.
Thanks, Bill. That was a great presentation. Do we have any questions for Bill?
I was just curious, how far back in time can you go?
Sentinel goes back to 2015, and on the tool, we've got the dates on the drop down. Depending on which satellite you choose, it'll tell you how far back it goes. I think Landsat 5 goes back as far as, I think, in the mid-80s. So you can, we've looked for, in the mountains here, we've got hemlock woolly adelgid that's killed all the hemlock in the mountains. And so it's using some of those longer term satellite baselines that allow you to look at that. And also the climate engine can go back and has a lot other satellites that you can pull from, MODIS, Landsat, Sentinel.
Could you go back to the mangrove slide?
Sure.
Other questions about that.
This one?
Maybe one or two more right there. With the black, one more down with the, there you go.
So I noticed that there's no mangrove showing all along the Caloosahatchee, yet that's a pretty much mangrove dominated system. Is it because the source material came from maybe the Clark Reserves or something?
Now this gets into the accuracy of the masking. So you're going to have to bring up your point with the Florida state land use people, why they're not mapping that as mangrove. So if you come up one slide, one up. There you go. So even there, you're saying there's a lack of, maybe, I don't know whether it's spatial resolution. See, this is based by the quality of the mask being used. And the quality of the mask I'm using is from NLCD 2019. So if NLCD 2019, if they didn't call that forest, it's not showing up in the mask. And so that's kind of why I like to make my own masks, because then it's right. Then it's current. And I usually make the mask from the pre-image. And so that's the immediately, you're deriving the land cover yourself. So unfortunately, now, if you need what's called an all lands, I can do that as well. So unmask it, do all land cover, all land use, and not have it masked at all. That's possible too. We call that all lands. And then you could look at those 10-meter pixels that are covering mangrove forest that never was identified in either of these two data sets as one. It wasn't ever identified as forest, and it wasn't ever identified as mangrove. So here's that bucket slide. It's the quality of the information that you use is going to give you the level of level of confidence that you want. And so it's really easy to blame other people's masks if you use their mask. If you create your own, you get blamed yourself. But the easiest way is to use someone else's masking, and that's, unfortunately, in this case, you have just highlighted a deficiency in both those data sets. And the answer to you is if you'd like, I'll rerun this analysis in seconds and give you an all lands. If you feel that, why don't I do that for you? Why don't I add an all lands in 1 year NDVI change image? And how that'll differ is that, you know, you'll just be getting all other land uses and land covers. You'll be getting urban, you'll be getting ag change, urban change. That's the answer to your question. And then another answer would be to create your own mangrove mask somehow. And I'll stop there.
Well, is a tool good at mapping emergent herbaceous vegetation as well as forested habitat? And then I don't suppose it has any applications for submerged vegetation.
Yeah, that's a little bit out of my realm to be able to answer that with, you know, fully. If it's emergent and can be, you know, the kicker here is but with a 10-meter pixel, you know, if you've got emergent vegetation and it's filling up that 10-meter pixel, 30 by 30 feet, then yeah, you can map it. But if it's kind of sparse or on the edges, then a lot of that pixel is going to be open water, which is really an NDVI. It just tanks NDVI. There's no NDVI. So, you know, you're going to have to deal with that gradation of change. And, you know, I'm just not an expert at answering that question. I'm sorry.
Thank you.
I have a question, Bill. Are the layers from the tool available for offline export? So could we pick up the NDVI and export them to desktop GIS?
Yes, I think there was a little bit of in and out cut off in your question. I'll restate it. So you're asking how to get the image out using this tool?
Yeah, if it can be exported outside of the tool.
Yes, sir. How it works is the email address that you sign up with, it writes it to Google Drive, G Drive, you know, by automatically, you know, you can create your own or use your personal Gmail account or create a very specific Gmail account email address just for use with that. And when you have a Gmail account, it automatically comes with a Google Drive or a G Drive kind of repository where you can store things. And so this version of HighForm, when you say export, it writes to Google Drive. It'll create a directory called HighForm export products, and it'll write the product to Google Drive.
Thank you. All right. Any other questions? Going once.
One more follow-up. Can you upload your own imagery to this, or are you limited to the Landsat and Sentinel?
Wow, that's a great question. Yes, you can upload your own imagery. You can upload your own shape files for like clipping and masking. So yes, you can, and you know, I haven't really done it with imagery because really all the imagery that we use, even NAPE, NAPE is up there on Google Earth Engine. So yes, you could. I mean, you could do it. Now with our HighForm tool with the little user interface that sits on top of it, no. You'll need to go to that blank sheet, and I can give you a script that essentially does the HighForm workflow, and then it's within there that you can add data and manipulate and do change analysis with your own data. But you're going to need to upload the data to Google Earth Engine, which is totally an acceptable thing to do.
Actually, I have one more question as well. So you can do a time series using this tool, so not just a one pre, one post. Have you had a chance to look at perhaps the change over several post images to see if there was perhaps some stresses that played out over a longer time, that weren't wiped out straight away during the hurricane, but perhaps there was some sublethal stress that months later played out, and you can see it on the change map?
Absolutely. You know, as long as you have the cloud-free imagery to support the analysis, you can do it as many times as you want. You can either, make it exclusive of a certain time period, or you can include it. And we just did that with, we'd call it change of the change imagery. How did the change imagery change? And so that's a little bit difficult, but how we addressed it with southern pine beetle just recently is that we map one long period, like we did here, and then we come in behind it afterwards and map something, a really short-term time frame, whether it includes the disturbance dates in the 1 year or whether it's exclusive of the dates used in the 1 year. And then we have two products. Then we have a 1 year product, and then we have a really short-term product that we lay right down on top of it. And you can toggle on and off of that, and you can see the long-term change. But then with regard to this example, you could see 1 month change, 4 weeks change. And so you're getting at an important topic here is delayed mortality. We see that all the time with wildfire. The trees, you'll get an image, but it may take them 2 years to die. And so, yes, you can come in after that as many times as you want, whether it be a broad time frame or a very narrow time frame. As long as you have cloud-free imagery, you could do. I mean, we did a 5-day change, and we're mapping southern pine beetle 5-day change, just because we have the imagery, and 10-day change. And man, you look at the difference between those two products, the pre and you can see how much they've advanced and how much it's spread. And you can get at delayed mortality that way too. So yeah, it can be as short as 5 days, as long as 10 years, 5 years, a year.
Thank you very much. Okay, thanks again for the presentation. Great tool, and I think for all of us in the environmental field, remote sensing is becoming so accessible these days that really it's got to be part of our toolkits. So thanks again, Bill.
You're welcome. Thank you all.